Imagine moving to a new city,
Yeah.
right? And to get your bearings, you decide to just entirely memorize a map.
Oh, wow. All right.
Yeah, you memorize every single street name, every intersection, every one-way sign. You just study the grid until you feel like an absolute genius navigating your morning commute.
Right. You've essentially just hard-coded the route into your brain at that point,
Exactly. The navigation is totally locked in. You know the exact sequence of lefts and rights to get from your apartment to the office without even glancing at your phone.
which feels great, I mean, until something changes.
Right. Because you wake up the next morning, step outside, and the city planners have completely repaved the entire town overnight. The roads are just entirely different now.
Oh, man.
The avenues are boulevards, the one-way streets go the opposite direction, the bridges have been relocated, and that map you spent weeks memorizing is no longer just useless, it is literally actively misleading you into oncoming traffic.
Yeah. You are back to square one, just completely lost in a city you really thought you understood.
And this relentless, exhausting scenario is exactly what we are unpacking today for you, our listener. Welcome to the deep dive. Today, we are targeting a major source of burnout and overwhelm for software developers, which is the, frankly, terrifying pace of changing technologies.
Yeah. It really is terrifying.
It is. And our source material today is a foundational document detailing the core philosophy and the curriculum structure of the Mobile Coding Academy.
And, it's very revealing text because it addresses this existential crisis in software development totally head-on. The document actually opens by describing a scenario that will sound painfully familiar to anyone in tech.
Oh, absolutely.
You spend months learning a specific software framework, you buy the definitive textbooks, you build the demo projects, you finally feel competent, and then like a year later, the creators of that framework announce it is deprecated.
Yep, the industry is just moving on to the next paradigm.
Exactly. Which forces the developer to ask a genuinely agonizing question, right? Like, did all that learning just become entirely useless?
Which brings us back to our city analogy. I mean, if you only memorize the street names, you will constantly be lost every time the city planners change the grid.
Right.
But if you take a step back and learn how to use a compass or understand the underlying grid system of urban planning, you have the underlying principles. You can always find your way, no matter where they move the roads.
And because that technological map is constantly shifting, we really have to examine what happens when developers try to navigate using the wrong strategy.
Yeah.
This is the core problem identified by the Mobile Coding Academy. The document asserts that developers are falling into a very specific, honestly very dangerous trap, which is that they are merely memorizing APIs or application programming interfaces instead of actually understanding the engineering principles beneath them.
And the source specifically points out who is most vulnerable here, which is super interesting. It's developers who are overwhelmed by changing frameworks, or people frantically preparing for technical interviews, or, those who just lack a strong engineering foundation to begin with.
Yeah, the pressure is real.
Right. You get stressed, the cognitive load gets way too high, so you just start memorizing lines of code like it's a vocabulary test. You memorize the exact syntax to fetch data from a network or update a UI, without actually understanding the mechanics of how that data moves.
What's fascinating here is that the software industry actually encourages this trap.
Really? How so?
Well, it actively rewards API memorization in the short term. Like when you memorize the syntax of a new framework, it feels incredibly productive.
Oh, I see what you mean.
Right. You can quickly stand up a basic application.
Right.
You can pass a standardized coding test. You get this huge rush of dopamine because the compiler shows 0 errors and the app runs.
Totally.
But what you are actually doing is building a highly fragile skill set. It's basically a house of cards that completely collapses the moment the technology updates.
Okay, let's unpack this, because I want to play devil's advocate for a second here.
Go for it.
If I am a developer and I have a mortgage to pay, and I have a massive technical interview on Friday for a job I desperately need, isn't memorizing the API just the most practical, fastest way to get the job done or, pass that interview right now? I mean, I can always learn the underlying principles on the job after I secure the paycheck, right?
I hear that a lot. But the problem with that approach is that the breathing room you are counting on never actually arrives.
Oh.
Yeah. The framework you are memorizing is just a temporary tool. If you don't understand the principles governing that tool, you are going to have to start your learning process from absolute scratch every single time the tool changes.
And it always changes.
Exactly. In the tech industry, the tool always changes.
Yeah.
So yeah, you might pass Friday's interview, but you are essentially signing up for a career of perpetual starting over.
Sure. But If boot camps and academies delay teaching the specific bleeding-edge mobile tech to focus on foundational principles, aren't their graduates at a massive disadvantage? Like against someone who just spent 12 weeks purely memorizing the exact tech stack a major employer uses today.
Only for the first few months of their employment.
Really? Just a few
Yeah,
months?
because the developer who memorized the API becomes highly effective very quickly. But then they plateau instantly when an edge case arises that the API documentation doesn't cover.
Oh, that makes sense.
Or worse, when the framework updates and deprecates the functions they memorized. The developer who understands the principles might take slightly longer to ramp up on the specific syntax initially, but they can debug complex issues, optimize performance, and most importantly, seamlessly adapt when the company inevitably migrates to a new tech stack next year.
Right, they aren't starting over.
Exactly. The cognitive load of constantly memorizing new vocabulary without understanding the grammar of the language leads directly to the burnout the source document describes.
Wow. Yeah, and if memorizing APIs guarantees this cycle of burnout, we really have to look at what happens when developers try to use this strategy in the wild. And Android development over the last decade is basically the perfect graveyard for this approach.
Oh, absolutely.
The source document provides a really brilliant case study of this, tracing the evolution of asynchronous programming in Android.
Yeah, for anyone who has worked in Android, this timeline is going to trigger some serious flashback.
I'll bet.
The document walks us through the specific evolution of the tools used to manage background threads and update the user interface. It started with async task,
Right.
and developers spent months mastering the intricacies of async task. Then the industry realized its flaws, and the new standard became RxJava.
But developers didn't just abandon async tasks on a whim, right? I mean, the mechanics of Android forced the change.
Totally.
Because async tasks caused massive memory leaks if a user simply rotated their phone screen. The activity would be destroyed and recreated by the operating system, but the async task would just keep running in the background.
Yep, holding a reference to a dead activity, and eventually it just crashes the app.
Exactly.
And so RxJava solved that lifecycle issue by introducing observable streams. It allowed developers to explicitly manage subscriptions and dispose of them when the screen rotated.
But RxJava wasn't exactly easy, was it?
No, not at all. It required an entirely different mental model. It was a massive paradigm shift into reactive programming, and the learning curve was essentially a sheer cliff. Like, a single typo could result in a 50-line stack trace of RxJava internals that was nearly impossible to decipher.
Ouch. So the community pivoted again.
Right.
Kotlin Coroutines became the new standard. And coroutines allowed developers to write asynchronous code that looked completely sequential, solving the readability problem of RxJava's massive operator chains. They suspended and resumed execution without blocking the main thread.
And then came Flow to handle streams of data within coroutines.
Right.
And shortly after that, Stateflow to manage states specifically. So just look at that staggering sequence: async task to RxJava, to Kotlin coroutines, to Flow, to Stateflow.
It's crazy. A developer who only memorized the syntax of how to implement these specific tools would have had to completely relearn that portion of their job 5 separate times.
Yeah.
They would have experienced that soul-crushing feeling of their knowledge becoming useless over and over again.
If we connect this to the bigger picture, this is the Mobile Coding Academy's core insight. The tools changed constantly. The syntax was completely different each time.
Yeah.
But the actual engineering problems they were trying to solve, managing background threads, preventing memory leaks during configuration changes, updating the UI safely without locking up the app, those core constraints of the operating system remained exactly the same across all 5 iterations.
So the underlying physics of the Android environment didn't change at all. Only the tools used to navigate those physics changed.
Precisely. Frameworks are temporary, but engineering principles are long-lasting. Frameworks are merely the tools, but the principles are the actual skills.
Yeah.
If you understood the mechanics of thread management and memory allocation, picking up coroutines after knowing RxJava isn't starting from scratch. It's really just translating your existing architectural knowledge into a new, slightly more efficient dialect.
Here's where it gets really interesting. Think about this in terms of structural engineering. Imagine you are tasked with building a bridge, right? First, you build it using wooden beams. You learn the properties of the wood, how it handles tension, how it distributes weight.
Okay, follow you.
Then, a few years later, you are asked to build a bridge using steel girders and maybe later advanced carbon fiber composites.
Right. The materials and the specific tools required to manipulate those materials have completely transformed.
The interface has changed entirely. You can't use a carpenter's saw on carbon fiber, but the underlying principles of load distribution, tension, compression, and just the fundamental law of gravity are identical. In software, the gravity is memory management, data state, and thread life cycles. If you only memorize the exact specifications of a wooden beam, you are entirely useless when handed carbon fiber. But if you learn the principles of structural engineering, you can adapt your designs to any material they hand you.
And the tragedy of the API memorization trap is that we have an entire generation of developers who are essentially just memorizing the specs of the wooden beams.
Oh.
Yeah, and they're panicking every time a new material is introduced to the market.
Because realizing that the fundamental engineering problems never change forces a complete rethink of how we should be educating developers in the first place, doesn't it? I mean, if we know the tools are going to change 5 times in a decade, teaching the tools first is a fundamental pedagogical error.
It really is.
And this logic leads directly to the specific curriculum roadmap designed by the Mobile Coding Academy.
Exactly. The source document outlines a very deliberate 6-stage journey to mastery. And the sequence of these stages is radically different from the standard coding bootcamp model, which usually rushes to get students building visual apps as fast as possible.
Right, so the 6 stages outlined are Stage 1, Engineering Mindset, Stage 2, Technical Foundations, Stage 3, Programming, Stage 4, Mobile Technologies, Stage 5, Architecture, and Stage 6, Professional Growth.
And the most revealing aspect of this blueprint is what is conspicuously delayed.
Mobile Technologies isn't until Stage 4.
Exactly. You don't even touch the specific mobile frameworks, the Android or iOS specific tools until stage 4.
The structure intentionally forces students to wait. It delays the mobile technologies until the foundational engineering mindset and programming concepts are firmly, unshakably established.
I feel like most developers want to jump straight to stage 4 because they want the immediate gratification of dragging and dropping buttons onto a phone screen.
Of course they do. But the Academy recognizes that jumping to Stage 4 creates framework users, not engineers. Oh, that's a great way to put it.
They force you to build the foundation first. Stage 1, the engineering mindset, involves understanding how a computer actually works at a lower level. Like, how is memory allocated? What is the cost of an operation? How do different data structures impact performance?
Right.
You have to understand the physics of the bridge before they let you touch the carbon fiber.
So what does this all mean? If I'm listening to this right now, and I'm a developer staring at a massive, 800-page documentation site for the absolute newest bleeding-edge framework that just got released yesterday, how do I practically shift my brain into this engineering mindset first step? How do I stop myself from just falling back into the habit of memorizing the code snippets on page 1?
That is the big challenge. The very first step is to forcefully step back from the how and start interrogating the why. When you look at a new framework, your instinct will be to ask, how do I write the syntax for this? You have to suppress that instinct. Instead, ask, why does this framework exist? What specific historical architectural problem is this tool trying to solve that the previous tool failed at?
Ah, so you have to look under the hood immediately to find the mechanism.
Exactly. You have to look completely past the API. Let's take the evolution we discussed earlier. If you are learning Stateflow in Android today, don't just look at the syntax for collecting a flow. Recognize that under the hood, Stateflow is fundamentally implementing the observer pattern.
Right.
It's the exact same fundamental software design pattern used in model view controller architectures back in the 1990s. It is a way for a subject to notify a list of observers when its state changes. Once you recognize the observer pattern, the specific syntax of Stateflow just becomes trivia. You already know how the engine works.
That shifts the entire perspective. You aren't learning something brand new. You are just identifying an old concept in a new wrapper.
This raises an important question, and it's one the source document specifically uses as a reflection prompt for its students. Think about the technologies you've learned in the past that have completely disappeared from the industry.
Yeah.
What were the lasting principles beneath them that you still use today?
That is a highly practical mental exercise for you, the listener. Just pause and think about a tool you used 5 years ago that nobody uses anymore. The time you spent mastering it wasn't wasted if you extracted the underlying lesson about data flow or user experience or component coupling.
Exactly.
The paint job faded, but the engine you learned to rebuild is still powering the new tools.
And training yourself to always look for the engine makes you immune to the fatigue of the hype cycle. You
Hmm.
stop feeling overwhelmed when a new framework drops because you know it's almost certainly just a new variation of an old theme.
Right.
You analyze the trade-offs of the new tool based on established principles rather than blindly memorizing its documentation.
Which brings us to the ultimate engineering takeaway from the Mobile Coding Academy. The thesis statement of their entire philosophy basically distilled down to a single mandate: learn principles, master any technology.
It really requires a fundamental rewiring of how most people approach technical education. It requires patience and a willingness to delay the immediate gratification of a working prototype in favor of deep comprehension.
But the payoff is a career characterized by longevity instead of burnout. Applying this to your day-to-day life, whether you are prepping for a massive tech interview that is keeping you up at night, whether you took some time off and are trying to catch up in a field that feels like it moved light years ahead, or, whether you are just fundamentally exhausted by the constant, unyielding influx of new tools on your feeds.
Yeah, we've all been there.
We really have. Adopting this engineering mindset shifts your career from a state of constant anxiety to one of adaptable mastery.
You step off the treadmill, you stop running just to stay in place, and you start building a cumulative body of knowledge. Every new framework you encounter just reinforces your understanding of the core principles.
You become the navigator who understands the compass, the terrain, and the stars, not just the commuter who memorized the temporary street names.
Exactly.
But before we wrap up today's deep dive, examining this source material got us thinking about the trajectory of the industry, and we want to leave you with a final provocative thought to mull over.
Yeah, so the source document proves, using historical examples, that frameworks inevitably die while principles live on. That has been the unbreakable rule for the last few decades of software development.
Right.
Humans identify a problem. Humans write the frameworks to solve it. Humans deprecate those frameworks when they find better solutions. And then humans painstakingly learn the new ones.
But the landscape of software engineering is changing again, and the pace is accelerating exponentially. As artificial intelligence and coding assistants become vastly more capable, we are rapidly approaching a point where AI writes the temporary frameworks and the APIs entirely on its own.
It's true. And if an AI model can generate thousands of lines of boilerplate syntax in a millisecond and instantly adapt its output to any new API specification, then the human ability to memorize an API is no longer just fragile, it is completely obsolete.
Wow.
The AI will perfectly master all the temporary tools faster and more accurately than any human mind ever could.
And if the AI takes over the role of the temporary toolmaker and the syntax generator, then what is left for the developer?
That's the million-dollar question.
Right. A deep human grasp of those foundational engineering principles, the architecture, the why, the fundamental logic of the system, the ability to recognize the underlying patterns. It won't just be a nice competitive advantage. As the tools become automated, understanding the principles might very well be the only software development skill left that actually matters.
The only thing separating the engineer from the machine will be the comprehension of the physics behind the code.
So tomorrow morning, when you find yourself in that proverbial city and you see that all the roads have been changed and repaved overnight, yet again, well, don't panic. Don't frantically start trying to memorize the new street signs. Just reach into your pocket, pull out your compass, and you'll know exactly where to go.